Good morning, everyone. I can see the number of participants ticking in. I will wait a few seconds more before we start. All right. Good morning and good afternoon to all of you attending our second Maritime Insights webinar from the Ammonia Energy Association. My name is Sofia Fürstenberg Stott and I have shared Maritime Directorship for the AEA. We have invited you here today to learn about a very exciting and forward-leaning project from Singapore. We will hear about the ammonia bunkering safety study currently taking place from the Global Center for Maritime Decarbonisation. The full title of this project, I just learned, is Defining the Safety in Operations Envelopes to Enable Ammonia Bunkering Pilot and Demonstration. And so today we have invited two speakers. It is Mr. Wei Jie Lau, he's Director of Research and Projects of GCMD. And we have Dr. Imran Ibrahim, who is the Principal Consultant and Head of Research and Development with DNV Maritime Advisory, Southeast Asia, Pacific and India. So the way it works here today is that, first of all, I would like to point out that this meeting is being recorded. The meeting will take a full hour and the recording will later be publicly available. And so I would like to start with saying a few bits about the AEA for those of you who may not be too familiar with us. We are a global non-profit industry association, and we are promoting the responsible use of ammonia in a sustainable energy economy. The AEA's mission is regards both the decarbonization of ammonia for existing applications, as well as the adoption of low-carbon ammonia in new applications. So that could mean the direct use as a fuel for electric power generation, or not least, as here, maritime transport. It can also be the indirect use as a hydrogen carrier and a carbon-free energy commodity. And so we were initially founded back in 2004. And over the last few years, we have seen an incredible growth as ammonia energy becomes something of the great target for decarbonizing the industry overall. So today we have more than 159 corporations around the world. I'm not sure that is the actual latest number, as we get new members every day. So as Maritime Directors for the AEA, we are working as a bridge. We are trying to help the maritime industry understand how they can engage with the ammonia energy sector, and vice versa, help the ammonia energy sector understand how they can engage with the maritime industry. And so we are trying thereby to help the industry engage in this low-carbon ammonia fuel opportunity. So this, I mentioned, is the second webinar of this series. And so we have the luxury of being able to handpick, select projects taking place around the world where we think there is where we think there is a lot of learning for our members and for this audience. So we want to illustrate how solutions are being found and how progress is being made. And we have mapped over 100 maritime ammonia projects taking place around the world. So for sure, we have a big pool to select from. And we are carrying out these webinars to raise awareness, to create a better understanding, and not least to connect the stakeholder environment out there. And I can already now say that our next webinar will take us back to Norway again on June 13th. We have invited the Maritime Coalition, who will brief us on ammonia fuel ships and networks, and there will be a sign-up link at the end of this webinar. So, the ammonia bunkering safety study. This study has just recently, I would say, started. And when I invited GCMD for this webinar, one of the first things is what they said was this, that they have just started. And this is exactly why we reached out, because we are interested to understand what were the reasons for engaging on this topic, and where do they hope this will take us. And so the Global Center for Maritime Decarbonisation has engaged DNV to lead this project, and DNV is also one of the partners of this center. This is one of the projects that we have found with the largest number of stakeholders involved. So the whole Singapore maritime stakeholder environment, in one way or the other, has a role to play in this project. And the project is taking a value chain approach, and they are going beyond feasibility. They are digging into the technological details, and they are looking into very specific areas related to the operational transfer of ammonia bunkers out of Singapore. And so it's a scientifically rather rigorous project, and safety is at the center of this project. And when we prepared for this webinar, Wei Jie said to us that if we can make it in Singapore, we can make it anywhere. So this is why I think this project is of such interest to an audience. And we have 82 participants following us right now. So this is really great to see. Without further ado, I would like Wei Jie to start setting the scene for this conversation. And Julian, can you help us with the slides, please?
Thank you, Sofia. So yeah, let's start with the first slide. Okay, so everyone, hello. I'm Wei Jie here. I'm Director for Research and Projects at GCMD. Let me run through very quickly who we are and our thoughts and thinking behind why we went ahead with this study. So maybe Julian, travel to the next slide. So a very brief history about who we are. We were first announced in 2021 April by the then Minister of Transport, Mr. Ong Yi Kang, to set up a global center for decarbonisation here in Singapore. So our founding was in April 2021, so that's about 8 to 9 months old as of today. So we were founded by 6 private partners and also with MPA. So each of our 6 private partners actually contributed $10 million cash towards GCMD setup over 5 years, and MPA is backing the center with another $60 million in terms of project funding towards the center. So 2 months into our existence, we decided to open an invitation for proposal in October 2021 to invite competent stakeholders in the industry to submit proposals for this study. So that was back in October 2021. And fast forward the next slide. So we awarded this study to DNV, Savannah, Jurong, and Singapore Maritime Academy as a consortium in January this year. So the idea is that this project duration will take about 10 to 12 months to look at the safety operations envelope for ammonia bunkering and demonstration here in Singapore. And I'll go through a bit more about that later, very shortly. So maybe the next slide. So a bit about how GCMD thinks about projects. So there are actually 4 tracks that we are looking at. Firstly, is really on ammonia bunkering. Next is on the assurance for drop-in green fuels. Third is on shipboard carbon capture, and fourth is on near-term retrofit solution. And we think that ammonia bunkering, the reason why we started with a study is because we wanted to actually do a pilot and trial in Singapore. So that was our aim. And when we look around for standards, when we look around for procedures, we realized that there is actually none. And that is also the reason why we think we want to work backwards towards first defining the safety envelope in order for us to start the pilot and trials in future. And if you look across the timeline, there are three key milestones that we hope to achieve. The safety study has already been announced and it's ongoing. That's why you see a full blue circle. We intend to actually run a proxy asset trial. And the reason is because we understand that major engine makers expect that the engine will only be ready in 2024, 2025. So we think that we can only do a pilot with operational assets sometime in 2025. But definitely this is also subject to change if we do get updates and technology developments that allow us to push this earlier. Yeah, next slide. So we understand that the fuel for tomorrow will be largely different from today. If you look at this chart, if you compare the characteristics of conventional fuel against other low or zero carbon fuels, you will see that they have very different boiling points, very different energy density and toxicity as well. And specifically for ammonia, there is actually some challenges that we see. So instead of us highlighting this as just challenges, we want to see what we can do to address this from a fuel perspective. Next slide. So our interest in GCMD is not really to duplicate work. In fact, this piece of work that you see on screen is done by our counterparts at the Maritime Energy and Sustainable Development at Nanyang Technological University here in Singapore. They have actually compared what is the difference between ammonia as a cargo and ammonia as a bunker. I've also put the link down if you're interested to see the actual presentation. But essentially, we know that we're not starting from zero because ammonia has been carried as a cargo. What we need to answer is how different is ammonia as a bunker and what we need to do in order for it to be handled safely. So in terms of the project-wise, may I trouble you to go to the next slide? There is actually 6 scope and outcomes that we wanted to address. So firstly, we want to look at what are the regulatory gaps and make recommendations to address these gaps. Next, because we are all about pilots and trials, we want to identify up to 2 sites for the actual bunkering here in Singapore. And third, for us to do so, we think that there's a need to draft the technical guidelines and procedures in order for us to move ahead with the trials. And fourth, we think that from a cost perspective, there is interest from our stakeholders to look at the CAPEX, and this is something that we are delivering as part of the project. And also number 5, we think that for ammonia to be handled, definitely the crew competency will need to be addressed, and which is why this is also part of our scope. And again, because the intent is really not to just do this for GCMD's purposes, we do want to validate and finalize the findings with our industry stakeholders. So we do hope that at the end, we can get a regulatory sandbox for pilots and trials for this project. And just as Sofia mentioned very rightly, because of the way Singapore is a very small country. If you look at our anchorage, it's a very busy anchorage with 1,000 ships around every day. So we do think that if you can actually allow ammonia bunkering here in Singapore in a safe way, it can actually be proliferated elsewhere. And of course, we recognize that there are regional challenges that one needs to address. But we think that if we start with Singapore as a good base, this can actually help to proliferate the learnings instead of getting everyone to start from zero. Perhaps we go to the next slide. So this is in the red lines, exactly where we are concerned with for part of our study, looking really specifically at the red arrows, the transfer processes as what we see. We know there are ongoing projects looking at the design of the ammonia bunker tanker, design of the ammonia fuel ship. So this is actually not within our scope, but rather we're talking about really the transfer part. Next slide. And we think that to do that, we do need a very long list of stakeholders, from your low carbon fuel suppliers to your port and terminal operators, bunker suppliers, vessel operators, vessel owners, or even the Institute of Higher Learning who tell us about the sort of quality and quality assurance mechanisms that needs to be in place. We also think that shipyards will be involved from a perspective of providing us with certain designs in the vessel side of things. Next slide. And this is how we actually got together our study partners. One interesting fact that you might not know is when we launched the study in October, that was 2 months after our founding, we have actually already secured our partners. And the idea was that whoever we choose in terms of the consultant, they have to work with these 31 partners. So on the left, you see from a fuel producer, we do have Yara, all the way to our shipyards. These are all the different partners across the supply chain. From the quality measurement perspective, we're also engaging the National Meteorology Center and also some of the testing labs that you might be familiar with. Next slide. From a regulator perspective, we are also very thankful to have NPA as one of our founding partners. And from them, we do get access to global platforms and local regulators. So we think that this is important when we talk about discussions with regards to the use of ammonia as a fuel. We recognize that this is going to be a new fuel, so there's going to be discussion not just with one of the regulators, which is NPA, but also with different agencies, for example, economic agencies, environmental agencies, facilities and land use, of course, safety as well. And we think that it's only if you bring together a comprehensive group for discussion, that is where you can start to identify what are the gaps to be addressed and how does the sample look like. And again, of course, this project is ongoing, so we expect certain changes in terms of the participants from the regulatory side as well. And definitely along the project, we do see that we will engage them as and when it's needed. Next slide, please. And of course, I would like to also welcome everyone here to participate in our study as well. So this is actually under the Industry Consultation Alignment Panel. What this does is that when the project is at the tail end of the study, we do want to actually share the findings with some of the interested parties. And through the QR code, you can actually sign up and receive the information firsthand before it gets public or it gets published to the regulators. So before I end this call, I do think that I would encourage everyone to sign up for our ICAP and in order to be updated about study. Now I'll hand over perhaps to Imran or Sofia. Yeah, thank you very much for your attention.
Thank you so much, Wei Jie. That was really great. Yes, moving swiftly on. So we are very delighted to have Dr. Imran Ibrahim with us here, and we are curious to hear about the approach being used for this study and some of the experience DNV has in performing ammonia-related studies as well. So please, Imran, welcome to the floor.
Thanks, Sofia, and good morning and afternoon to everyone online again. Happy to present the work here, which we have entitled actually GAPS or GCMD Ammonia Bunkering Safety Study, which DNV is leading. Next slide, please. So the slide here builds on what my GCMD counterpart Wei Jie has mentioned in terms of providing why DNV is interested in this project. It boils down to enabling ammonia as a marine fuel, both safely and sustainably. The intent of this work is to enable scalability of ammonia, and as Wei Jie has mentioned, establishing a regulatory sandbox for pilots and projects in Singapore. Two work streams are being developed here, and I will articulate this further in the next slide. And engaging the wider industry is also very important. And in this aspect, 21 study partners are involved in this two work stream, ranging from the fuel producer Yara to the regulators here in Singapore. And also, as mentioned, DNV is partnering with Subarna Jurong as well as the Singapore Maritime Academy in this project. Next slide. So the slides here illustrates the various phases of the work stream. This has been developed from the scope and outcomes that has been mentioned by GCMD. So workstream 1 articulates a more specific aspect of the project, which involves developing a bunkering demand forecast, basically to project how much ammonia is expected to be used as a marine fuel in Singapore, and fitting that data into the conceptual designs, which covers the various bunkering modes. This results in sites being selected for the specific ship-to-ship and truck-to-ship bunkering modes, and finally resulting in the safety studies involved. Also, a CAPEX model will also be developed in this work. As of any research work, I think there will be some elements of iterations involved from points 1.2 to 1.4. In workstream 2, on the right side here, a draft guideline for ammonia bunkering will be developed, articulating introduction, custody transfer, bunkering and safety procedures, as well as the training and competencies requirements. So next slide, please. So for the ammonia bunker demand forecast, the methodology undertaken here is both including a bottoms-up and a top-down approach, requiring inputs from individual projects for ammonia, as well as publications done internally from DNV, which includes the energy transition outlook. So what's being developed here is it's like a dynamic reporting format, which, depending on the assumptions that had been undertaken in the forecast, could result in some variations in the uptake of ammonia. So all in all, though, our forecast at this stage predicts that the uptake of ammonia will take off sometime in mid-2030s. Maybe the next slide. Inputs to the forecast will go into how the conceptual designs of ammonia bunkering will take place. In this case, 4 modes of bunkering, that is ship to ship, shore to ship, truck to ship, as well as cassette, will be developed. So this is emphasized in the design basis. Within the infrastructure design, the key undertaking here is process design, that is the development of process flow diagrams, heat and mass balance, as well as others. Finally, the availability of the sites as a function of the adequacy assessment is performed. Preliminary safety distances have to be developed, and there have been some studies that could be cited as a basis of these distances. Next slide, please. So one of these studies here is actually one that DNV had performed in the Port of Amsterdam, shown on the left side on the slides here. So this work actually includes analyzing other gases beyond ammonia. This is hydrogen, LNG, and methanol as well, and determining the location-specific individual risk, or LSIR, or external safety distances. Additionally, focus areas determined by fire, explosion, and toxicity also determined as well. On the right side, we've also performed a study on the Port of Oslo, developed for 3 main transfer concepts. So the first one is a pressurized ammonia for a truck, to a pressurized storage tank on the quay and further to a passenger ship. The next concept is a refrigerated ammonia from a bunker ship to a storage tank on the quay, and then further again to the passenger ship. And finally, refrigerated ammonia from a bunker ship on the seaside of the passenger ship, directly next to the ship as well. So all these concepts will be similarly hashed out in this current work with GCMD. The next slide, please. The exercise on the conceptual design, as well as what you can see here on site selection, will be determined by our partner, Subrana Jurong. So Subrana Jurong is a renowned engineering consultancy in Singapore. The methodology of this site selection would encompass 4 steps here: screening, evaluation, selection, and shortlisting. Development of the screening criteria and evaluation of the methodology has already been conducted in some previous analysis. Scoring assessment is also will be conducted with a group of technical specialists, and consultation within the agencies in Singapore is then performed. Next slide, please. The safety studies performed in this project involves identifying hazards in both hazard and HAZOP exercises. So this includes analyzing both consequences as well as frequencies or likelihoods. Taking into account considerations of these 2 factors, mitigations into the consequences as well as options to decrease these likelihoods will be explored. So if these are not managed, further analysis, including the use of computational fluid dynamics, as well as other qualitative risk assessments, will be performed. Next slide. So as a final step to workstream 1, as I've mentioned, a generic CAPEX model will be developed. This involves understanding the work breakdown structure, or WBS, of the infrastructure required to enable ammonia bunkering. So taking into account the conceptual designs of the bunkering scenarios, as well as the estimate of cost templates, preliminary indications from Subrana Jurong shows an approximate of about 40% of the cost estimates will be determined. Okay, next slide. In workstream 2, This involves drafting technical and procedural competencies guidelines. These have actually been articulated in a technical reference 56 or TR 56 on LNG bunkering. In this workstream, collaborations within the study partners, which includes meetings, workshops, will be conducted, and the resulting deliverable here is a document consisting of 4 parts. As I mentioned, the introduction of ammonia as a marine fuel. Part 2 will be on custody transfer, basically determining quality and quantity measurements. Part 3 is on the safety procedures of bunkering, articulating the safety considerations within the 4 scopes. And finally, on training and competencies requirements, which involve the requirements for ammonia bunkering operations. Next slide. So just wanted to pull you back to the overview again of both work streams 1 and 2. These are the work streams that will be involved in the work with GCMD. I think as mentioned by Sofia as well, this is under development. So as of now, we'll be able to share, of course, the approach of the project at this stage. So over to you back, Sofia.
Thank you so much, Imran. That was a lot to think about. And I have prepared a few questions up front, and I realized that some of those questions already have answers in your slides. But I will nevertheless take the opportunity to challenge you on some of the questions we have for you. And after that, we will invite questions from the floor, and I can see that they start ticking in under the Q&A tab over here. But so starting with you, Wei Jie, I mentioned that this is a value chain driven project, and we can count around 20 industry partners involved, and more than 30 more contributors are somehow connected to this project. Yet you share a link here in your presentation inviting more partners or contributors to get involved. And so in that regard, have you identified any parts of the value chain or the wider stakeholder environment that particularly you feel is missing, and why is that?
Yeah, thank you for the question. I guess if we look back at the whole project itself, and when we map out the whole stakeholder, definitely there are certain parts that are maybe not visible here. For example, one of them would be your cargo owners, people, or even fuel purchasers. We do recognize that some of them really have a strong view, or perhaps even they are the ones who decide what sort of fuels they want on their ships. So they are actually a very important stakeholder. But I guess when we talk about narrowing the scope and boundary conditions, and because this project was really specific on the safety elements of it, we decided to be a bit more targeted in who we want in the first 21 partners in order to really deliver that first result. Ultimately, this will then proliferate on its own. I'm quite sure, we hope actually that the results can be used by other people. And definitely, again, this is not our last project on ammonia. So that is where new partners come in, depending on the role they play. We do think that the cargo owners will come in at a certain point in time, fuel purchasers will come in at a certain point in time. Yeah, just that, for boundary purposes, we can't really include everyone in that sense.
Yeah, of course. Thank you. You mentioned here something about how this work can also be used elsewhere. What key deliverables from this study do you think are specifically relevant for other locations in the world? And similarly, what is very Singapore specific here?
Okay, so I'll first answer what is the one that perhaps can be usable elsewhere. I think one of it could really be the technical reference documents that we're developing. I'm quite sure everyone wants to understand from a handling perspective how ammonia can be handled as a marine fuel. We think that whether it's here in Singapore or in Rotterdam, there could be some adjustments depending on your local authorities, local constraints. But more or less, I guess the couplings, how it's going to be done, is going to be similar. What might be a bit more specific It's really the site that we are selecting. That's one of the outcomes that we want. And I must say the reason for this is because we want to really move on with our pilots and trials. And without that kind of specificity, we will still need another study to identify the site, which is why that will be a very, I would say, Singapore-centric piece of work. But behind that piece of work is really the framework, the thought process about how a site is selected. And that, I think, is also deployable elsewhere. Again, with taking into consideration of local constraints, it can actually be a bit different. But at least that sets people thinking from a piece of work that has been done, instead of starting from ground zero.
Yeah. In this regard, Wei Jie, I mean, I've been many times to Singapore myself, and often overwhelmed and fascinated about everything that is going on at the same time over there. And so ammonia is not the only renewable fuel that we are hoping to deploy in maritime. And so I would think, and Imran also mentioned studies taking place in Oslo and Port of Rotterdam regarding methanol, not least. I guess that when you are identifying this site for ammonia bunkering, you also have to take into consideration where can we place other fuels if they are to be bunkered here as well. Could either of you share some thoughts on that complex jigsaw puzzle?
So maybe I can start first, and Imran can add on.
Yeah.
So I think in this study, I must admit that it is really focused on ammonia, but I do suppose that when we talk about safety consideration, I think I saw just now Imran mentioned about the adjacency. So there will be some considerations, but I don't think it is our intent to start to build a multi-fuel terminal for Singapore. Yeah, but rather more specific on ammonia, and also the consideration if there are adjacencies, what are the safety requirements in order to make sure that ammonia bunkering can still happen safely. Imran.
Thank you. Imran, do you have a comment there?
Yeah, no, I think DNV has always been espousing a multi-fuel scenario that will be upon us, and at least from my opinion, as a bunkering hub, Singapore should be cognizant of that fact. So understanding all the risk and opportunities perhaps and cost, involving storing, bunkering, all the different types of fuels has to be considered perhaps sometime down the road for Singapore.
Imran, could you share a little bit if you are basing this work on existing codes and regulations to some extent, and how you are maybe hoping that this will lead to new guidelines and standards going forward?
No, definitely. I mean, we are aware of the fact that there are existing codes within IGF, for example, and IGC, which has not articulated, the safety considerations of ammonia as a fuel. But beyond regulations as well, we are also leveraging on other publications. For example, there was a work in INERIS in 2005, which experimentally tabulates all the different dispersions for gases beyond ammonia. So these are the things that we are looking for, scientific technical reports that we could look at and consider risk, involved. For example, if there's a rupture scenario, I'm trying to be a bit specific here, perhaps. Yeah. So we are, in a sense, not leaving perhaps any stones unturned, not just looking into perhaps what's available already within the regulations, but also within scientific publications and technical reports. What
is your timeline ambition here? If the results of this study is going to be brought into bunkering safety regulations at IMO level, what is your ambition timeline here for that?
Yeah, well, I can say with regards to the work of GCMD here, it's until the February 2023, which is 12 months from when we were awarded. But perhaps Wei Jie would be able to articulate further beyond that then.
Yeah, so I guess because GCMD itself, we are a non-profit, we don't have direct access to IMO. But we do work with regulators, we do work with our partners, and where possible or opportune, we do want to actually share these findings upwards to IMO platforms or other international platforms. Again, because part of our mission is to shape standards, we think that if we have a base document that allows you to start conversations, we do want to reach out to different platforms to start these kind of conversations. So again, that's to really to help harmonize things and so that ammonia bunkering can happen sooner rather than later.
Yes, thank you. I'm gonna bring you back to the actual site discussion because I think I can see that several questions are already popping up regarding that. And I am also interested to understand the discussion around if it's going to be a fixed location in the port or if it's going to be maybe a floating installation outside of the port, and understanding the factors involved for such consideration. Would you be able to share some thoughts on that?
Yeah, as I mentioned, this is still being undertaken, but what we can perhaps share is that we are aware that Singapore is very congested, perhaps residentially as well as industrially as well. So we have to be again cognizant to those facts. And when it comes to having a pre-consultation with the agencies here in Singapore, we have to bring in tangible evidence why a specific location would be safe in accordance to the distances near residents, for example. So again, depending on the outcome of the QRAs, perhaps a more specific analysis with regards to airflow have to be conducted, but this is downstream within the work here. Yeah.
Thank you, Imran. We have received a number of questions up front prior to this going live, and I'm going to select a few questions from there. A very technical question to start with from Satinder Virdi of the Singapore Maritime Academy. What could be the possible type of tanks suitable to handle ammonia as marine fuel?
Yeah. Within our rules, DNV rules, we have articulated some design specifics that for ammonia. So this includes, a tank system that is capable of keeping pressure and temperature within the design limits of about 18 bars. So if it's less than 18 bars, vaporized ammonia would have to be handled by a BOG or a boil-off gas system. So typically, a holding time shall not be limited to 15 days, and pressure accumulation will be accepted as boil-off gas handling philosophy only if a tank is beyond 18 bars. So yeah, there have been some specific recommendations from our rules. What I recall as well, we are open in terms of having ammonia being stored, whether it's a type C or type B, or even a membrane type of tank as well.
Thank you. Several of you out there are wondering about where the ammonia supply will come from. And we have one question from Nitin Chandran, if I pronounce your name correctly, who is asking where else than from Australia will Singapore source the ammonia? And will you rely on multiple or single source suppliers?
Okay. I must say, from a supply perspective, it wasn't covered in the scope of this study.
Yeah.
So we are agnostic in that sense because our concern is if it does come to Singapore, what do we do with it and how do we manage it? So I don't have an answer for that, I must say. Yeah.
I recognize that. Where could they place such a question, Wei Jie?
I got no straight answer.
Maybe I can, because I did a bit of digging here. I think there's already some export volumes from Russia and Trinidad, as well as even Indonesia. But beyond the traditional means of how ammonia is being developed, from the Haber-Bosch process. The green ammonia here is limited. So from there, typically it's from only Australia. But yeah, I think if we are serious in terms of decarbonizing maritime, so we have to consider green ammonia, and we have to consider, basically how it's being produced.
Thank you, Imran. And I will bring us back to the safety focus here. We have a question from Carl Wistad from Amon, who's asking, how will you ensure compatibility towards different tank technologies and ammonia conditions?
Yeah, sorry, can you just repeat that again?
Yeah, he's asking the compatibility towards different tank technologies and ammonia conditions.
Yeah, I guess this is quite specific and technical, beyond the traditional means of how the tanks would have to be specified within their own makers. I think it has also definitely have to be verified from class.
Yeah. Thank you, Imran. Panos Stavrakakis is asking about the main health and safety risks. And he's actually wondering if you have any ideas about the numbers of people who may likely be exposed out of ammonia bunkering in Singapore and how the level of risk is being measured.
Yeah. I think I've mentioned a bit on LSIR as well as the exposure guidance, but beyond that, there have been some works from, I think, if I'm pronouncing his name correctly, Karabayoglu, on the effects of ammonia concentration in air by volume, as well as the EPA guidelines on acute exposure guideline levels, or AEGL. So these are typically expressed in parts per million. These are applied within the agricultural as well as the refrigerant safety studies. So we will be leveraging, I think, these two applications for ammonia as well for bunkering.
Yeah. We have a question here from Liana Bonnet, which came in through the Q&A here, following a little bit on to what you said there, Imran. She says, considering the dispersion of ammonia and the associated risk contours, we anticipate significant barriers to use of it as a bunker fuel. Do you see any innovations on the horizon that will help to reduce the event or probability at the bunkering site or the consequence of an event? So she's looking for innovations for safety here.
Yeah, I think beyond what has been articulated with regards to water spray deluge systems, for example, for the manifold to limit the spread of ammonia, as well as perhaps a remote operable, having it remotely operable from a location, or mechanical spray as well. There has limited, it's sort of innovation with regards to mitigation, but I think we have to be also aware in terms of understanding the likelihood, or the probability of this dispersion, and not just focus on beyond the consequence, perhaps. So this will all be uncovered within our hazard and hazard studies. I think if we are focused on perhaps the consequence, it does not paint perhaps a good picture, as with any gases with regards to any the worst case scenario for any gases. That's what I'm trying to get at. Yeah. So the likelihood or the probability of that sort of occurrence should also be considered to paint appropriate risk profile.
Imran, there have been several safety-related ammonia studies taking place in Singapore lately. We have an Itochu Vopak study, and we have a study governed by the McKinney Møller Center for Zero Carbon Shipping, etc. How are those projects in any way or form being absorbed into your work?
I'm not so familiar with the study within Maersk, but with regards to the Itochu work, I'm fairly aware that there's even a larger consortium involved in that work, in that project. But what I can say, and you have also mentioned as well, Sofia, is that our work will be based on scientific justifications and technical reports. And what we want to develop here will be as close to as possible a realistic scenario, to enable bunkering. So that's why we included a demand forecast, to understand really the numbers that we are looking at.
Yeah.
And then from that, put it into the conceptual designs.
Maybe I can add a bit about how we see things play out.
Sure.
If you look at the different consortiums that have been announced around here in Singapore, I guess they're looking at very different parts, or I would say different but yet similar parts of the whole equation, which is, of course, the end goal is to enable ammonia bunkering as a commercial business here. Some are looking more at the vessel design, some are looking, bunker vessel, some are looking more at the ship that is using ammonia as a fuel. How GCMD, when we first did our study, we also asked this question to ourselves: how do we support the different studies? And which is the reason why in our study we are focused on the safe handling of ammonia as a fuel. We are very much focused on the bunkering process, because we think this is going to be a common challenge across the different stakeholders. And our idea is really to support all the different consortiums that come in that wants to look at bunkering here in Singapore by providing them with scientific-based results that what Imran mentioned, in order to enable them to actually do the different processes that they're looking at.
Thank you for that. We have several questions here that really have not so much to do with safety. So I'm trying to sift through here to give you the really juicy questions to think about. And so with regard to this kind of regulatory development or standards and the hope that this project is going to kind of lead the way on developing that. Can you imagine kind of on a very high level here what the gate stages could be? I asked about the timeline here, but that's just one thing. But if we can vocalize those gate stages and what we here in the room here today can think about with regards to how they can, how we can improve the progress of those gate stages. Would you have any reflections on that?
Again, because our end goal is to do the pilots and trials, so this is always in our mind. So of course, with the end of this study, this is going to come up with what we call a draft technical reference, or at least a really prelim form of it. In Singapore, we do have our standards committee that we need to share this document with them to sort of officially put this as one of the considerations when we talk about developing standards. So once the standards is published, or at least in a more ready state, the next thing we want to do is actually to work with the regulators to identify and also to discuss whether the two sites that we identified can actually be used for ammonia trials. So now, on one hand, you have the procedures being set in place. On the other hand, you have the site being set in place. So that will be our next gate that we need to clear. Then third is really to look at stakeholders who are interested to move this journey with us. When we talk about deployment, GCMD, with our limited resources, we can't really deploy ammonia fuel vessels just for the purpose of trials. So we will actually be engaging with different stakeholders who are keen or have already engaged on similar projects to put in resources to really demonstrate the first pilot and trial. So that will be our third gate that we are thinking about. Once that is clear, we do foresee that we need to change some of the technical references because nothing beats operational experience. And that actually sort of refines the whole technical reference document. Before then, it goes into a more ready state. And that is when I think we feel ammonia bunkering can happen in a more business as usual, although that's not the best word to use, but rather it's a more BAU manner.
Thank you. Imran, do you have anything to add to that?
Yeah, no, I'm just like what I've mentioned in terms of the steps 1.2 to 1.4. If you recall my slides, there is a constant iteration between innovation as well as regulations as well. So yeah, I think within the, like what Wei Jie is mentioning, we see perhaps a more scale up uptake of ammonia sometime in mid 2030s. This is a function of after the engine makers have already developed suitable engines for ammonia, as well as then enabling pilots, and then supply chains have also evolved to kind of have the market prices for ammonia be justifiable for it to be uptaken as a fuel. So yeah, a few considerations down the road there.
Imran, what has been the reasons for DNV to engage at this level in this study?
Yeah.
Why is this important for DNV?
Yeah, I think this is one of the many scenarios that we have forecasted within the energy transition outlook, and to enable proper decarbonization of the maritime field, we have to explore beyond ammonia, the multi-fuels I've mentioned. And it's of course in DNV's interest to be involved with all the different stakeholders who would be determining this fact. Yeah.
Guys, I just came to think about a question I've been sitting on here, and that comes from hearing about other initiatives out in the world who have similar challenges as you. One example comes to mind is something called the Bornholm Bunkering Hub, where they are looking into the port of Rønne becoming a bunkering port for ammonia. How can these kinds of initiatives lean in to your work and kind of, as your work develops, maybe take knowledge and instead of having to embark on their own journeys all alone, how can they engage with a project such as this?
I guess the most immediate answer is really to invite the different players to join ICAP for now. So that is really the most direct way to get access to the information. Because in ICAP there is actually a consultative process that we take in the input, so they could have their own considerations that they think is important that we might have missed out. It is also very important that, which is why again that they've sent us this, so that we can actually be a bit more holistic in our approach before we publish it to the public. Yeah, and again, because GCMD, we're not going to do this study and keep this within our database. This is going to be made public. So we welcome anyone who takes this up and also customize it for their own use in their different operating environment.
Thank you for that. And Wei Jie, when will the results from this study be publicly available?
I'm looking at Imran.
Yeah, I think the plan is still February 2023. So yeah, we are working on that timeline. Yeah, super.
We have somebody worried here in the chat. Nick Bentley is saying that the majority of two-stroke engine manufacturers, they have said that they will have engines available for ammonia by 2025 latest. And then we heard you mentioning 2030 here for green ammonia production to scale. How and this is outside, of course, of this safety scope, but if you can allow to give some considerations with regards to these challenges we have to make everything come together in parallel at the same time. How can we ensure that the first vessels operating on maritime ammonia have somewhere to bunker?
I'm just actually reading the AEA IRENA report published just a few days back. So I'm just saying that only 15 million tons of renewable ammonia will be ready by 2030. So I mean, looking just at the figures and what the maritime need is actually quite far. But again, because we think that what GCMD actually calls this study a no regrets move. Regardless it's green color ammonia, gray color ammonia, you still need to address the safety hurdle. And we think that because it is a no regret move, we want to start early so that we can actually clear out as many challenges as possible as early as we can. Yes, engines will be there by 2025. We do suspect that at the initial start, it's going to be a blend of your green and grey ammonia. And that is also why, I guess in my slide, we talk about the drop-in fuel assurance, really to provide people with certain traceability on how much is the green, how much is the grey content. But once that is done, I guess then as more green ammonia kicks in, this is where the blend percentage can actually go up. And that's how we see it playing out. It won't be an immediate overnight change, but because of this, we also cannot wait for regulations. We cannot wait for production of green ammonia to be ready before we start thinking about the regulations and the technical references. In our opinion, that might be a bit too late. Yeah.
Yeah, thank you. Wei Jie and Imran, I will give you one last opportunity now to tell this audience your main message that you want people to leave this session with. And if you can limit that to 2 minutes each.
Okay, so I understand there's a lot of challenges that there's to be with ammonia. So which is why GCMD decided to take the first step in getting these documents out. We welcome any inputs. We don't have the solution for all, but I guess as long as we work towards a more collaborative effort and complement each other's work, that is where I think we can actually move towards a more decarbonized maritime space.
Thank you.
2 minutes.
Imran?
Yeah, I think I'll end with what my maritime CEO would typically say, collaboration is the true fuel of the future. So yeah, as you can see, we are involving a wide range of stakeholders here in the study, and as we just mentioned, the ICAP, we're still looking for partners within the ICAP as well. So do share your thoughts as well if you have any with regards to this work.
Thank you so much. Julian, on the backstage, can I ask you to share the details for our next webinar there we are, fantastic. So I'll take the opportunity here to also promote and take note of June 13th, 9 o'clock Central European Summertime, where we have invited the Maritime Maritime Network to tell us about their ammonia fueled ships and networks. There will be 2 projects here, the Viridis bulk carriers joint venture and the ammonia fuel bunkering network being established in Norway. Wei Jie and Imran, it was a great pleasure to have you with us today. And I'm so happy that we had such an audience joining us as well. And as we said in the beginning, the recording will be made available, the presentations will be made available, and don't hesitate otherwise to reach us to us. And we look forward to having more maritime members at the Ammonia Energy Association. My name is Sofia Fürstenberg Stott, and this is it. Thank you very much.
Thank you, everyone.
Thank you, everybody.